All right. So what I'll do at 9 a.m. is that, we won't do any preliminaries. I'll just let you guys figure out the programming quiz. It's kind of 170 material, or I should say HLP2 material. And then I'll kind of talk a little bit more about why I gave that particular assignment and matters related to that. So it kind of will take will take that particular problem and sort of speak about things that we want to learn and do this semester. Okay, make sure things are correct. All right, it's open now. The quiz. Uh, it's kind of like the regular online grading. There's no safe browser, nothing, right? So you could program on your own computer and upload the assignment. There's no specs. I'm not giving you anything other than what you see in front of you. Refresh your browser, my friend Clementine. How do you submit the quiz? Just like normal. You have to click on the link and upload your file. And I'm presuming all of you are aware of how that works. No need, my friend. I mean, the main thing is to complete the solution. And if you have time, document it for your own convenience. Please, I mean, if it's a quiz, it's going to be graded, right, my friend? Why are we spending this time doing that rather than me teaching? It's just for me to know where you are. And since you're putting in the effort, you got to get a grade. So anything to do with quizzes and assignments is always graded. Seems like some of you are coming in late. There's nothing other than the description that you see in the quiz. There is a driver online. You write the code and upload it, and it'll tell you whether you got the grade or not.
Hi, Professor.
Yeah.
Yeah, sorry. So, for the submission, we just have to save in the web page,
I mean,
or do
you
we have
like
to create a new file?
you have to get yourself graded,
Okay,
right? Just like you turn in an assignment, think of it as an assignment. What you normally do is finish and then upload, right? And then click the submission button and it tells you whether you did your stuff correct or not.
okay, got it.
So same idea, nothing's
Nothing
changed.
changed.
All right, you should submit whatever you got so that you can get some grade. It does give partial credit because it's going to close in the next few seconds. Okie doke. All right. What I'm going to do is begin by solving the problem. Anything I do, I'm going to obviously put it up online. But what I really want to do is get into some advances in C++. And this is a very good exercise for me to kind of talk about how we used to do things and how we are going to do things in the coming decade and in the future, right? Okay. I'm going to go ahead and share my screen and so that everybody can see how I turn on my computer and my compiler and all that stuff. Okay, so this is where I want to code, and I just go CMD. I'm using my WSL, which is the Linux subsystem, and I'm going to go ahead and open up my Visual Studio editor. And I think we were supposed to write a source file called lines. All right. And I'll write the driver in a moment. But hang on, what's going on? Oh, I have to first get into WSL, excuse me. There you go. And then I go in here. And so this is not so complex. In my opinion, it's something anybody who's completed 170 should be able to accomplish. And
hello, Prasanna, Professor
yep,
Prasanna. My submission is like stuck on evaluating.
that means you have an infinite loop. So it's going to cut out after a while. It has a maximum time and then it will dump your thing. It doesn't go for infinite, right? Because it switches off. So I set up a timer.
But I compiled it on my Windows, so it didn't have an infinite loop.
So it's a good teaching moment. Just because it worked on your computer, we shouldn't jump to the conclusion that it has no bugs. Okay. Right? Because it obviously is working for a lot of other people. It worked for me. So the machine is not the one that is got the problem. It's not the compiler and it's not the hardware, because we have to assume that those are correct. And the driver is correct because I tested it. So I think it's an infinite loop. So don't worry about it, right? The amount of points that you lose is insignificant compared to actually figuring out what's going on, and it's going to help you out in the future. So let's not worry about it. Time's up. I don't want to worry about it. I have 175 people, so I want to keep moving. Okay. It's a quiz. There's going to be many quizzes, and it's not like going to significantly affect your grade. It's nice to get an A in everything, but I'm just saying don't get too stressed out. Okay, can everybody see my screen?
Yes.
Can see.
Can see, and can you read what I'm typing?
Yes.
Excellent. Okay, so I'm going to do it the easiest way possible, right? I just finished 170, and the things that we get taught at the end of the semester, somehow they don't stick because you got a lot of other stuff, and life gets really busy. So we need to kind of take a function, define a function that sort of looks like this. I hope you didn't forget the basic idea, right? So this is an array, or than a pointer, I should say more clearly, but let's keep things simple. This is the array that was passed. Each element of the array is going to be containing the address of the starting character of a file name, right? And since we don't have the number of elements, the last element of the array is going to contain the null pointer. So that's how I know we are reaching the end. So what I do here is essentially define an iterator, because I need to iterate through the array. I can use pointer arithmetic, but we'll leave it for another day. And then I need to accumulate the number of lines, right? So sum is going to be my accumulator. This is modern C++ syntax, right? We don't use the sort of like the assignment token and all that stuff. This is straightforward. I is being initialized to 0, so is the case with sum, and there's only one way to initialize, at least in my mind. And what I do here is, this is how I'm going to navigate, right? I'm going to iterate through every single element of the array until I reach the null pointer, and the null pointer is going to evaluate to false, and I get out. But I didn't test this. In the future, I will. You got to test whether this itself is a null pointer. So the proper thing potentially that we should do is this, right? This is called sanity checking. When you are working at Tesla writing software, you can't make assumptions about how people are going to drive and or whatever, right? So this is called sanity checking, where some guy sends you bad stuff. You're not doing bad stuff, right? You're protecting yourself. You're going to return sum is equivalent to 0, and that is a proper value to return. So this gets evaluated first. You don't want to put this like this, right? Again, goes back to HLP1 and what we learned about, short circuit behavior and so on and so forth. Okay, so these are the basics. So I am iterating through every single element, and I'm not sure how you did it, but there's a couple of ways in which you can do it. First thing, I am not going to do any error checking further, because it's going to obfuscate the content itself. If you're working at Tesla from now on, you want to basically check if the file is open and so on and so forth. For our purposes, I'm not going to do that because it'll increase the size of the code and takes away from the intent. Now, what is it that I want to do? I want to read every single character, right? So you had, it's an open book thing. So if you didn't know, you could have easily looked this up in the appropriate location on your textbook, in your notes, or online. And you are going to now iterate through every single character. And right away, I need to keep track of line count. So I'm going to go ahead and define another variable here called line count, initialize it to 0, and I'm going to continue reading characters and checking if each character is a new line character. And it's easy enough to do that. Yeah, line count, no, I'm doing the condition. There. Right, I personally think nobody should be using an if else and all that stuff, because you're writing on one line, your boss, your teammates, everybody is going to be really happy with you if they can just scroll from left to right rather than go up and down 4 lines. So here I am. I'm iterating through each, so to speak, file. Within each file, I'm iterating through every single character, keeping track of which one was a new line and which wasn't. And anytime I come across a new line, I increment my line count. And once I'm done, I'm going to go ahead and accumulate, right? This is my accumulator. And that's really all there is. This is all you have to do, right? And then you return line count. I don't think there's anything more. Obviously, you come back and look at it because I'm speaking to you as I talk. I do notice
Professor,
that. Yeah.
I believe you mean some.
Yep. Thank you. And also, I forgot to increment this iterator, right? So, that's the perils of speaking and coding. But that's really all there is, guys. And I know that many of your projects, Ellie actually requires you to do this. I don't know if it gives you the code, the way to do this, but now you know how to do it yourself, right? And it's trivial. Now, the point is, I'm going to actually put the driver right here. The point is, this is old style programming. So I want to sort of use today to sort of introduce the C++20 compiler, right? And not get into details, but sort of start exposing you guys so that you, if you're interested, can spend more time because you are writing projects and so on, and try to take advantage of some of these features. So obviously, I'm going to put in the necessary headers. What do I need? I need the iStream business. I probably need somewhere I'm going to print. So IO stream. But for now, let's keep that as simple as it looks. And now I'm going to go ahead and implement my driver. And the driver was implemented like this. So online, when you submitted your code, there was a driver that looks like this. And what it's doing is it's basically updating, reading the information and then creating a new array and then passing that to you guys. All right. OK. Let's say we don't want to deal with any of that. And instead, I want to kind of sort of get into showing you a sort of some of the, like I said, the sort of exciting things that are going on, right? And for me, the biggest thing that is going on in C++ is this really big shift from object orientation and so on, and more into sort of like stream programming, like the way data gets manipulated, analyzed, and so on and so forth. And so let's try to kind of work for the first half of the semester quite a lot with the standard library because they've made it more and more powerful. And they're thinking about how C++ can adapt itself to all the different problems that have come up since 2011, right? Data science wasn't big 10, 11 years back, but now it's considerably big. And C++ is trying to adapt itself to how to take advantage of those things. So what I'm going to do here is I'm going to go ahead and take the stuff that you see here and put it into a container, right? So first of all, I want to create a container called files. And this is going to become important as we move on. Now, can somebody tell me how can I take the contents that are provided by the user and encode them into this particular container? So in other words, you're running the program. Let's say the name of the program is lines, and you go and say lines.out, and you provide the name of all the files that you wrote, right? You wrote f1.cpp, f2.cpp, f3.cpp, f4.cpp, let's say. And this guy is going to be an array of 5 elements, actually 6 elements. The first element is going to be pointed to this particular character. The second one is going to point to F, and so on. And the last one is going to be the null pointer. I want to take these things, which are really C strings, and use them to initialize my container. Does anybody have any ideas of how one can sort of achieve that purpose? So one way to do that is obviously, being online is very useful. To look at the constructors that are associated with vector. And you come in here and you click, obviously best to go to the latest version. And you can see that vectors can be initialized using a pair of iterators that specify the first and the last, right? And remember, iterators are nothing but pointers. And so do you guys think that this is going to work? Because we did learn about iterators in the previous class. So argv, what does argv represent? Actually, I don't want the name of the program, so I'm going to start like this. And I think I'm going to go one past the last, which is exactly what this is going to give me. Do you guys think that this is going to initialize all of the names that I typed and store them in here into this container, which is going to contain C++ strings? Anybody? So we'll do all of this in more detail as time goes by, but argv is an array, right? And so this is going to be the address of the first element. And the address of the first element is going to contain the address where the name of the file that you want to encapsulate into this container is going to be stored. So this, in my mind, makes sense because I'm giving the container iterators, which are really nothing but pointers to C-style strings, are pointers to chars, I should say. And then this guy is going to iterate through every single element and essentially call the string constructor to encapsulate those C-style strings. So we have now a container called files that's going to contain the names of all of the files that we wish to open. Now, what I'm going to do is I'm going to go ahead and iterate through every single element, right? And store the value that is returned in this particular container, which is going to contain, the result of each one of the lines in each one of the files. So I'm going to go ahead and iterate through each element. I'll just call it X. I'm going to go through this container, and I'm going to go and, you know, okay, so maybe what I'll do is I'll first show you guys that this code actually works and then do the others. So here, I'm going to go ahead and essentially get the result like this. I don't think I need to compile or add anything, so I'm just going to go ahead and compile. We'll just stick with 17 for now. Yeah, this is going to be a problem because I can't just copy this. So what I had to do was I had to essentially so the way I tested your code is let me see. How did I test your code? I tested your code like this. So I wrote some unit tests. If value is 0, then I basically created a array that I called argv, and I gave it one element, and that one element was initialized to be the null pointer. So this was the very first test. And then I called your function lines like this. And I printed the result that you generated, right? And in this case, it should be 0. Then I wrote a couple more cases. So if you got 2 correct, then you would get a 67%, right? If you get all 3, then you get the 100%. So here I created something with the one file so that you can get one thing to work, and we'll just give it to be the name of this source file itself. And so what I'm going to do is, for now, I just want to see if this stuff that we wrote works. And I'm going to just go ahead and compile. So then when you upload, the driver is going to, the online grading system will go ahead and compile your stuff, take my driver, and then execute it if it compiles, right? And links. And it actually automatically gives the input 0. And then it gets the result to be 0. So if you got this far, then what it'll do is it's going to actually no, it's going to run all the tests, and then it's going to determine which ones are correct and which ones are not. So here I'm going to pass in the input value 1, and it's going to say line 30. I'm getting okay. Yeah, it's 30 guys because I didn't press this. Right, because we are counting new lines. See, as soon as I press this and this cursor is at 32, I'm going to get 31 to be the answer. Right, so, you know, the cursor is here, but it's going to count new lines. So That's really all there is. That was what I wanted you to do, right? Now, what I'm going to do is, since I'm done with this, I'm going to show you the actual purpose behind why I wanted to.
Double check something.
Yep, go ahead. I'm going to leave this for you guys.
Is char constant? Are we passing in an array of pointers or an array of values?
You're passing an array of pointers to chars.
Okay, in the question, it was unclear that that was the case because you wrote takes in an array of file names.
Yeah, so in C++, you can't. If I do this, the compiler is not going to compile. That is the error message I got, because in C++, not in C, but in C++, this is an array of read-only chars. Not in C, but in C++. So there's no way this is going to compile. Nor can you write code that does this. This is not going to compile. It'll compile in C. And that is a problem with C. Even though this is a literal and is going to be stored in read-only memory, in C, the behavior is going to be undefined, because some programmer is going to say, I have P, it's a pointer to a char, I can go right to this block of 6 bytes. And then we don't know what's going to happen, right? It's undefined behavior. C++, obviously, coming after C, said, that is silly. It should really be a pointer to a read-only char, because this is an array of read-only chars. It's a literal. It cannot be changed. So it's going to go sit in what is called read-only memory. So therefore.
But the question isn't clear if it could be an array of strings.
But how are you going to create an array? And anyways, even if you got a compiler, you can see what the compiler is and fix it. Right? It's not going to change this particular content, the algorithm itself. Because if you're in C++, then, and you're saying, well, I want to do this, it's not going to work. I can't get it to compile, even if you decide to do it. So one of the things we learned in HLP1 is not to do that. Anytime you have an array of, pointers to so-called file names or whatever, they have to be pointers to read-only chars. And it said there very clearly, C style strings. Would you agree that it said C style strings? C style string. Because otherwise, what your guys are telling me is that I have to be so exact in this advanced course where I have to tell you what is the function prototype, what is the return. But then this is the third course, right? So I'm trying to get you guys to kind of start thinking sort of in a than the previous two courses, right? And again, like I said, this particular quiz, it's not worth a whole lot, but it also teaches us many things, right? I can't give you the function prototype and say this is what I want, because we are past that. That is HLP1 and HLP2. And it's not like I'm going out of my way to make it be complicated. Clearly in HLP2, we learned that C style strings can only be, I can't compile any of this stuff if I don't do what I did, right? I can show you. It's not going to compile. There. So I have to change this. And then this one, it ends up being a warning, but really it's an error, right? Because it says there very clearly, ISO C++ forbids converting a string constant to a char pointer. Now, it's the guys who designed G++ should really make it be an error. And one of the things I've always been stressing on you guys is turn all the flags on. Don't give me anything that has a warning, right? Because it leads to bugs. So this is incorrect. It's illegal code. Okay. All right. So I'm going to go ahead and get to where I wanted to go and what's going on. Let me just say I'm going to call it range .cpp because in C++20 they have something new called ranges, and I just wanted to kind of use this exercise to get there, right? And it's something that hopefully many of you would be interested in pursuing in your own code. So what I'm going to do is I'm going to go ahead and copy paste this and adapt it to what we need, right? Or maybe I'll just start from scratch. So I need to use the standard library, containers, vectors, strings, and so on. And I'll add more stuff as time goes by. So this is the situation that we were in. We wanted to actually have the user provide the names of the files on the command line, right? And what I'm going to do is start from the basics, okay? I'm going to go ahead and start by basically doing this, which is I want to take all of these C style strings and encapsulate them in a container. So I'll call the name of the container files. It's empty. What I'm going to do is I'm going to iterate through every single element of this, right? I'll assume that if argc is less than 2, that I get out of the program, right? So this is my sanity check. Otherwise, the user has some files that they wish me to go and compute the sum for. So I'm going to go ahead and iterate like I was doing. And essentially do this. Files, and one of the things we learned in HLP2 is pushback is not particularly a good idea. and instead we should adapt ourselves to always using in-place back, especially if you're going to make games, work on other kinds of projects. It is unnecessarily creating two constructors. One of them is this, and potentially the other one is if you use pushback. Here, at least we are saving ourselves from one constructor. And this string is going to be generated by using the file name that I specify, which is a C style string. Okay, so I got my container built in, and I'll later on come back and show you how we can get rid of all of this and do it in a much better way, right? Okay, so I got my container. So now what I'm going to do is I am going to go ahead and iterate through every single element of my files, and I'll call the name of the file, each one of the files in the container X. I'll go ahead and iterate through each one of them and call a function. And the name of the function is going to be in the example of an int, okay? Push back, in-place back don't actually do anything. It's only with containers that are more complex, like strings, which themselves require constructors. In this particular case, pushback, in-place back doesn't play any particular role in terms of efficiency, right? So here, I'm going to go ahead and call a function called count lines in file. And then I'm going to have one more step because we want to get into ranges. So I need to convert everything into sort of all these different stages. Then what I'm going to do is I'm going to iterate through every single element of my container, which is going to store the lines that were returned, the line counts that were returned by this function, and accumulate the sum. And then I'm ready to print. The files have our line count is so something simple became a little bit more complex, but that's okay. So the first thing I want to do is make sure I implement this function, right? So what does this guy do? This is a function that is going to take a string and I'll name and simply go ahead and compute the sum. So we'll forego testing sanity checks for a moment because it gets too unwieldy. As you can see, I'm already unable to see the entire code, but I'm going to create a open up the file stream and I need to store each one of the characters that I read, and then I need my line count, right? And we have done this before. This one needs to be initialized. So I'm going to go ahead and check. And I'm doing this is because a common mistake is to sometimes not type this and instead do this, and the compiler will actually flag this as an error. If you had done it the traditional way with this being on the left, then basically your, every character is a new line, right? So the program isn't going to crash, but you're going to get junk and then you have to debug. But here, right away, the compiler is going to say you can't assign to an integer, to a constant. And I'm going to go ahead and return. Okay, so this is going to work. We can test it. But what is the biggest problem that we see here? Well, we are kind of programming as though we are using C++ as though we are programming in C, right? We are digging deep into the dives. It's our job to iterate through, every single character. We kind of are more interested in telling the computer what exactly to do rather than in a sense telling the computer this is what I want to do, right? And you go do it. So the style of programming that you see here is sort of obfuscating the actual problem that we are trying to solve, because this guy, it has all these different variables and you got to make sure that every single variable is properly initialized. I didn't initialize this guy initially, so I'm going to get screwed. The program is going to crash or give us some incorrect results. So this is traditionally the way we tend to program, right? When we don't use the standard library a whole lot, because what we are doing is we are foregoing the convenience and instead we are telling the compiler or the system, I should say, exactly what you want to do step by step. And this is a pretty poor way to program. And what we would like to do is see if we can fix it. OK. And let me, just go ahead and test this so that everybody is convinced that this works. And then we'll start sort of fixing it. OK, luckily there were no errors. So I'm going to give it range.cpp, right? So what I should see is, I believe 39. OK, so we have 39. So far, so good. All right. What are the things that I want to do? Like I said, I want to go away from telling the compiler or the computer all of the individual steps. So I'm going to look for patterns. I'm going to look for sort of like a functional style that allows me to say to the computer what should be done instead of telling it how it is to be done, because that's what I'm doing. All of these 40 lines of code are essentially digging deep into the innards of what we need to do and telling the computer exactly what needs to be done. So let's start. The first thing we want to do is, let's see. Take this and sort of, this is something that is common for every file, so it should be something we can uh, encapsulate into a function. And let's call it, I don't know, count lines. And what does this count lines get? Count lines is going to get the name of the file. And what it's going to do is all the dirty work of figuring out what exactly needs to be done in terms of opening the file and doing all the work that you see here, right? So I'm going to see if I can copy all this stuff and paste it here. And this is going to count the lines in each file. Is everything good? Yes. All I need to do is return line count. And what I'm going to do with this is that I am going to give it, right? Because this stuff is something I can encapsulate into this particular function called count lines in file. So I'm going to go ahead and convert this to something that looks like this. So in other words, take as much work away from main and let main simply tell these functions, this is the data and you give me the result. Right now, there's a lot of busy stuff going on, boilerplate stuff. The most important thing is that we have a bunch of files. I want somebody to open each one of these files, determine how many lines there are, and tell me main, what is the total count, right? And right now, this guy is doing all the low level work, and that is generally speaking not a good idea. So here, what I need to do is iterate through each element. I'll call this files because that's what it is. And instead of returning an int, I'm going to return sort of a container that contains the line counts for every single file. And let me just go ahead and create something that looks like this. And this guy is going to be pushed back and count lines. So we're kind of making some sort of progress, right? So main is doing some sanity checks. This is sort of like saying main is receiving a container with the file names, because unfortunately in C and C++, we can't use the standard library with main as input. And here, all of this goes away. And instead, what we have is so a little bit better, but still not the best. So this is what I have, right? So this is boilerplate stuff. We are just taking the files and encapsulating them in a container. Then I pass my container off to this function. This guy is going through each file and calling another helper function that is going to go through each one of the characters in the open the file, deal with the actual innards of the file, and return a value, right? Which is sort of what I want. So this is looking a little bit better. And what we can do is test it out. Ah. Count lines. Count lines must receive the name of the file. So let's see if that fixes it. No return statement at line 21. So I need to return result. Okay. So what I'm going to do is run the program, and generally, this is what I do. If I want to check it with multiple files, I just give it the same file, right? If it works for one file, well, it'll work for another file. 88. So let me go down. Yeah, because this is where the new line is, and this is where my cursor is. So 88 looks good. So far, no problem. So what I want you to kind of think about is that we still want to make it be better. What modern C++ is telling us is that all this boilerplate stuff that you're writing is unnecessary work. It's busy work. And so what is the first thing I'm going to do? Like I said, I'm going to go ahead and start with this. For example, there is something in the library that already allows us to do all the work that we are doing here, all right? And that particular work is going to be done by an algorithm called the count. So let's see if count does the trick for us. Count takes the number of elements in the range and compare equal. No, that's not what I want. What I want is accumulate. So I'm not sure if you recall, but we talked about this, not in great detail, but we did talk about this in HLP 2. So this function returns the result of accumulating all the values in the range, right, to init. So clearly, this is something that I should be able to kind of do. And so this entire thing goes away. And what I want you to see is where modern C++ is going. We are doing something on line 36. What line 36 is returning to you is a container. We are taking that container and passing it to another function. Can you see that, guys? If you programmed in computer graphics, sort of like how shaders work, you are an assembly line in a car factory or somewhere else. Each one of these functions is doing something to the input data and is generating new output. That output is being supplied to another function, right? And so what C++ is saying, why do you want to write all of this in two lines? Why can't we combine that into a single line? And that's where I was going to get to, right? And we'll get there after we simplify the other functions. But am I making sense to you guys so far? Because I don't want to continue until I get some questions or something. And does anybody have any questions? So earlier we wrote a lot of boilerplate stuff in main, but now main is kind of getting much more simplified. It's taking its container, which contains the names of files, and passing it to this guy. This guy in turn is generating some other container. We are taking that container and saying, okay, I'm going to get the first element, one past the last element, and the accumulator value, which is 0. And then I'm going to compute the sum and give it back to you guys. So what is the, where is this guy? Numeric. So I need to make sure I add numeric to make sure that it compiles. So let's go ahead and run a test every time we change a little bit. It's good to kind of convince ourselves that the stuff we are doing works. Line 80, obviously, I mean, we kind of reduced the amount of boilerplate stuff that we were doing, right? Now, the question is, if I am applying that sort of an idea here, then why can't I do that here? Why? Why is it that I have to write all of this code here? When the idea behind C++, at least the standard library for a long time is, hey, get away from all of that and instead use abstractions. So the first thing I'm going to show you is how to reduce this to a single line. Okay. We can't discuss everything in detail. So today is sort of like the general picture of where my interests are in terms of C++, at least for the first half of the semester. And then the next half is going to be the more traditional object orientation thing. But notice what I'm going to do here. We are doing boilerplate stuff, opening a file stream, setting up some state variables, going through a loop and changing these variables, right? This guy gets updated every time we read a new character. This guy gets updated depending on whether this character is a new line or not. And there are many places we can go wrong. So what is it that we can do something similar to this in terms of here? And actually, you got a sense of what we can do right here. Because remember this function called count? What does it say? It returns the number of elements in the range that compare equal to val. So we got to change the way we think. Rather than thinking that a range of values can only be in a vector or a list or whatever, you really need to think anywhere where we have a sequence of data, right? And the data could be in a file, it could be in a network, it could be anywhere. And in the cloud, for example, if you expand this idea, right, and so on and so forth, then why is it that we can't take this idea and apply it to counting the number of lines in a new lines in a file? Because that is exactly what we want, right? And we can then get away from telling the machine how to do all these tiny things and instead just say, this is what I want. I want you to count, right? And so let's go ahead and try that idea. And this is where knowing iterators is going to be useful. And we'll spend some time writing our own iterators and so on. But for now, I'm going to sort of block this piece of code here out and implement our own version. So basically, I need to return whatever count is going to return, right? And count is defined in algorithm, right? This is something you should get really familiar with, right? It's got all these cool stuff. And so how do we kind of know about these things so that I can actually kind of write what we say is functional code. Okay, so I'm going to call the count, but in this particular case, my range is going to be from the starting character in the file till the end of the file. And what I want count to do is return the number of elements in the range from the very first character to the end of the file that compare equal to val. So what is val in our case? It's the new line, right? And I'm going to just go ahead and apply that idea here. So how do we do this? Well, this is where I'm I briefly covered this, and if it's new to you, don't worry about it. We are going to cover it. This is just sort of an introduction to where we are going. So what we are going to do is open up a stream, right? Which is going to be not a traditional file stream, but simply going to be based on a starting point in the file and one past the last character in the file. And this is given to us in the standard library, right? So we know what iterators are. Iterators are really nothing but uh, sort of pretty pointers, I should say, prettified pointers. So this guy is essentially going to be a pointer. And this pointer is going to be reading chars. So, and it's going to read chars from I didn't open the file, right? From this. So this is the file stream. I'm initializing this pointer to point to the first element in the stream. I need the end, one past the last element. And in the standard library, what they said is that this default constructed pointer to a char is going to be one past the last element. And in the algorithm that we have here, we got to give it the value that we want to count, right? And in our case, it's simple and straightforward, and it is going to be the new line. And so this entire thing goes away. I wonder if I can actually open this and get rid of this line. My dream is to have a single line. Let me sort of think about it. Can I do that? I don't think so. So all of the boilerplate stuff goes away, and instead this is a lot simpler for you to understand, your teammates to understand, and in turn combine this algorithm, count lines, with other algorithms. And I'll show you in a moment. So, but again, let's just go ahead and compile. Did I include iterator? Yes. Return count is not a member. Did you mean C out? Isn't it count? Algorithm. Did I not add algorithm? I didn't. Okay, so I'm going to go again. Actually, I'm going to just run the same command. What happened? Line count is 0. Iterator char ifs. Should it be buff? Let me try that. Okay. I lost track. And where do we get these sort of like learn about these things? What I normally tend to do is go to iterator and sort of just skim through, right? And when you kind of look at it, you get a sense of all of the different facilities that are available. This is what I should have used, but I didn't use. So iStream buff iterators are input iterators that read successive elements from a stream buffer, right? And that is what we have. And what I was using was this, which didn't work, that read successive elements from an input stream, such as CN. So if I'm reading from a file, I suppose it cannot be a traditional input stream such as CN. So the important thing is that we took all of this boilerplate stuff, which I'm going to get rid of, and converted it into something that looks like this. All right. And from 88, obviously we came down to 74. Okay, so this is good. But again, I'm doing some boilerplate stuff here. Can you see that, guys? I'm getting a container. I'm iterating through every single element of the container, calling some function called count lines, which itself has been made optimal. But still, this part is again going down and telling the machine, this is how I want you to do it, not what I want you to do, right? And how do I do this? Well, basically think of it this way. There is something I want to do for each file, which is I want to call this function for a file and get this particular function to return the number of lines. So in data science, this has become a popular idea, right? Because data kind of goes through in these streams. And I'm talking about, running analytics on Facebook data, Twitter data, and so on and so forth. What happens with that kind of data, if you think of Facebook or Twitter or any one of these social media things, the amount of data that gets generated, okay, is huge. So there's no way to kind of store the data somewhere. And then copy that data from the disk into a file, into a memory, excuse me, and do what we are doing, because you're talking about terabytes that are potentially being generated every instant of time. So what they instead do is they don't store the data. They take the data and pass it through all these different systems that perform a certain amount of operations to generate more useful data. And the old stuff gets thrown away until what you end up with is not the terabytes, but a much smaller amount of data, but that is more useful to Twitter. And that is how Twitter can say how many people liked this or how many people didn't like whatever, all the statistics that you get in social media are generally computed instantly, right, in real time. So these companies, they don't store the data. Instead, they take the data and sort of transform it one step at a time. And there could be hundreds of these stages. And that is sort of essentially become the way everybody thinks of data now. And essentially, that is kind of where we are trying to get to. We kind of are looking at that with this, but we haven't combined, right? I'm storing the intermediate result from here and then sending it here. What we would really like to do is combine these two things. So sort of like how things are being happening in the cloud. Okay, so come back here. Like I said, we know what to do with one particular file. Now I have a whole bunch of files. Anytime you have the same thing to be repeated over and over again, which is fairly common in data science, fairly common in actually a lot of different activities, we have exactly the solution for that particular thing, and that is called transform. So in other words, transform is one of the most useful things in C++, right? Why? Because I know how to do stuff on one thing, but I have to do that same thing on many things. Well, this guy is exactly what you need, all right? And no, I'm clicking on the wrong thing. It's transform. And what does it say here? Applies an operation sequentially to the elements of one or two ranges and stores the result in the range that begins at result. So in fact, this guy is a lot more powerful because notice it can take data from box 1, data from box 2, combine them in some special way and generate new data, right? Which is exactly kind of how things work in the real sort of in the cloud these days with data processing or data engineering. So let's see if we can take this idea and apply it to our function. See, I know what to do. For one file, I got to call this and get the number of lines. So what I would like to do now is to actually call this particular function on they transform. I use the transform to call it on all the files. So how am I going to do that? Well, let's do it one step at a time. First of all, I'm going to just do what I did earlier, which is, and then show you how we can think of using the transform. So clearly, this is going to contain the results of whatever operation we perform, okay? And I know that the size of this container is going to be the number of files. So I'm going to essentially create or initialize result to contain that many elements. Size or sizes, guys? Does anybody remember? I think it is size. So this guy is going to be containing the line counts of these many number of files, right? Now, the transform, remember what does it say? If you know how to do stuff on one thing, one file, I can help you do the same thing on every single one of them by sequentially moving from one file to the next without you having to do all that boilerplate stuff. And you know, anytime you do this boilerplate stuff, the idea is that we tend to screw up. So let's do it like this. So we start with the first file name, then we go one past the last. And what is the operation that we want? And where do we want to store the result? Well, that is where we say store the result here, right? So you're going to take each one of these files, do some stuff, and whatever you get from the result of doing that stuff, you're going to put into this. Am I making sense so far, guys? Do you guys want me to kind of stop for a moment? I need some feedback. Remember, I cannot see you guys. Am I going too fast? Am I taking the fun out of programming? Please tell me and I'll change my ways. Okay, no feedback at all. So I'll presume that I'm doing really bad and everybody is too nice to say you suck, but it doesn't matter. Once I start talking, I can't stop, guys.
Professor, someone is asking about the transform part.
Why don't they speak up? You have the freedom to speak so that everybody can understand, right? My friend, speak up.
Professor, I think it's written inside the chat.
I know, but I can't concentrate on the class and look at the chat, right? It's impossible. I can't do that.
Professor, can you repeat the part about the transform?
Okay. Yeah. So,
Thank you.
so basically, let me get rid of all of this, right? It's okay. We can come back and do this. So clearly you can see the pattern here, right? I have a bunch of files. For each file, I know what to do, which is call this function, give it the name of the file, and this guy comes back and gives us the number of lines in the file. Agreed? My friend?
Yes.
So when you know what to do with one and you want to lift, actually in data science, they use the term lift, Python, for example. If you want to take what you're doing on one item and you want to lift that operation on many other items, okay? Then we have exactly the solution for it, which is called the transform. And what this guy transform does is that it's going to go through every single file within this range, okay? It's going to apply this particular operation on each one of the files. We know what the operation is, right? Count files, remember? And it's going to return a result, and that result is going to go sit there. So rather than writing the boilerplate stuff, there is this beautiful thing called the transform that lifts your solution for one item to as many items as you wish. Did I make sense?
Okay.
Yes.
All right. Let's see. Let's go ahead. Maybe when I do complete it, maybe it might give you an idea. So we are actually doing that work. Notice I am creating a container with no elements. This for loop is iterating through every single element of this container. And what does this container contain? As the name implies, it contains file names. So a particular file name is called X. And what do I do? Well, I call this function called count lines and give it the name of the file. This guy goes and does its magic and gives me the number of lines in the file. And what do I do with those number of lines? I add it to this container called result. And then once I accumulated all these counts, I return the result back to whoever is interested in this. What I'm saying is that all of this boilerplate stuff where we think in terms of how to do things, we need to move into that phase where we tell somebody else how to do that. But obviously for them to do it, we need to say what to do. And in this particular case, I want you to transform every single element in this container, take it as input, call this function, which we call a transformation function. And what does this guy do? Takes the name of the file and spits out an integer that gives you the number of lines in the file. And so in a manner of speaking, this particular thing is actually one of the most useful things in the standard library, because in a way, it allows you to kind of get close to doing things as they do in Python and so on, right? With data science. And this guy has been around for donkey years, even before Python got invented. So we call the transform algorithm. And remember, we want the transform algorithm to apply a transformation function on every single element of this container. So we need to specify a range. And what is the name of the transformation function? It's going to be called count line. So we need to provide a function pointer, right? A pointer to a function. Because the name of a function is equivalent to a pointer to that function. So this algorithm takes the range of things on which you wish to apply this function. But this function returns a result. What do you want to do with the result? Well, the algorithm says, I'm going to tell me where to put that result. And I say, put it in result, because that's what exactly what result is meant for. Well, result doesn't exist, so I'm going to go create it. But result here is going to be expected to actually contain the same number of elements as this range. So what I do here, unlike earlier, is to actually initialize result to contain these many elements. So this entire thing is essentially going to do the work of what we were doing here. And once this algorithm gets done, result is going to contain the necessary information.
Professor, I think you forgot to add the std end of the result, for the fourth parameter of transform.
1, 2, 3, 4. You mean this one?
Yeah, as in like there should be an std end result, right? Should it?
No. Okay, good point. And good question. Excellent. So what the standard library, and if you were writing it, that's what I think you would also tell your users to think like, right? Which is, I am telling you that there are these many number of files, right? Say yes. My friend?
Right. All right.
Okay.
Okay.
So the idea here is that to make it easy for users to use it rather than to provide an additional parameter, they expect you to make sure that this guy is at least as big as this. If it doesn't, well, the program is going to crash and burn. So if this has to be at least as big as this, then you don't need to specify where the end is, right? Because it doesn't really matter. I'm not anyways going to use it. So for that reason, in general, when you have multiple such ranges specified in algorithms, we only specify the first one and let the compiler make the assumption that we, the programmer, has enough storage already specified. Okay. Now, what happens if you didn't do the initialization and instead you just did this? Well, the program is going to crash. It's a common error. But I don't want the program to crash, then you need to kind of do something else, right? And that something else is actually described here. I won't do that because we don't have the time today. It's called an insert iterator, okay? Do you want to insert at the back, which is what we want to do with the vector? So you would sort of use this adapter. And what the algorithm is going to do is it's going to say, well, the algorithm doesn't know anything, but basically now memory is going to be allocated, just like how a vector grows, right? While here, with the way we have written it, the vector is not going to be grown. Instead, it assumes that the number of elements in the vector exists, and this gives me a pointer to the first element, and I'm going to just step through. Okay? Did that make sense, my friend?
Right, right. Thank you.
Then I return result. Right? So what we have done now is gotten rid of this boilerplate stuff, and which is taking me to the last part, which is actually, you know, let's make sure everything works. And then 86. Well, there's been an increase because we're not taking advantage. $70, which is not bad. So we have this, and this is really boilerplate stuff. And I was trying to, that's what kind of get you guys to also, when you come across these sorts of scenarios, think, is there a simpler way for you rather than creating all these variables? And it's so easy to get wrong. Sometimes we tend not to do this. Is there a way to kind of grow or automatically initialize your vector, right? Which is files, and essentially provide a range of pointers to char, right? Because pointers to char can be used by a string as a constructor. So argv subscript 1, right? So this, no, that won't do the trick. Argv plus 1. So argv is an array. So argv plus 1 is going to be essentially a pointer to the second element of the array. And what does that particular second element contain? It contains a char pointer, right? And how far do I want to go? Well, one past the last element, and that guy is going to be given by argc. So this essentially should initialize your vector. What do you guys think? This is where, remember I started off and I said I'll come back to this. So this is where knowing your pointers comes in handy. Knowing your arrays of pointers comes in handy. Knowing your pointers to pointers comes in handy, right? So the more we tend to do things, what I'm learning in C++ is that C is critical. And in the next class, I'm going to show you another thing that got invented in C++20, and it's so brand new that even G++ doesn't do it, is the best way to print in C++ is going back to the days of printf, right? So we'll talk about that in the next class. But let's go ahead and give it a shot and see how it works. So I'm going to leave that to you guys to kind of think about it. And if you have any questions, we'll talk about it in future classes, because there is obviously some time put aside to think about pointers and complicated declarations and so on. So anyways, all this boilerplate stuff went away. So what is the size of my program? 30, right? So it's already come down substantially. And the less you write, the more you get done and the less time you need to debug. So we have now something nice. Now I want to get to the C++20 part, all right? And in the chat, I think the channel, I showed you guys how to install G++, a parallel version. We can't, we got this one will continue to do the 17 stuff, and we have another program that does the 20 stuff. So this particular thing that they invented in C++ is called ranges, right? And the idea behind ranges is this: you are specifying a range, right? This is where things can go wrong, and things generally tend to go wrong. What happens if you don't specify the one past the end properly, right? And why are you making programmers do that? If you know that result is a container, then generally speaking, I want to, specify the range of the container, and I don't want to have the begin and the end be specified. Why can't you, the compiler, figure all that stuff out? So the last part of what I want to show you today is sort of like a glimpse, right? You don't need to kind of worry about it. It's not going to show up in any exam, but it's hopefully going to give you a sense of where the language is moving forward, okay? And it's going to look like this. And I can't compile this anymore in GNU, so I'll use G++. But this is how it's going to look like. So we have the files. Files is a container. I do not need to specify to anybody begin and end. If I want the entire range of files to be transformed, then I should just be able to say files, right? And I want to be able to also chain together the idea that, hey, I am giving you files, you are giving me result, and result is being given to accumulate. So why can't I pipe all these things together? I have one of the first labs for the HLP1 is where you guys probably learned about pipes. Does anybody recall the idea of pipes that you learned in the very first lab 1 year back? Anybody? Because I'm pretty sure you guys did my lab, where you kind of explore Linux and Windows and do some pipes and redirections and all that stuff. No, that is what I'm going to do, because that is the idea behind one of the important things that got invented with C++20, and that is the concept of ranges. We no longer need to do any of this boilerplate stuff. The basic idea here is that, hey, I got some files. I want you to transform these files using this transformation function. All of the rest is baloney for me, right? Because why are you making me do all that stuff? So this is how C++ has sort of kind of moved into kind of, the realm of what people kind of do in Python and so on in relation to data science. Unfortunately, we got to use the keyword auto without me explaining the full details. And what I'm doing here is specifying the entire range. So rather than having to physically say begin files, end files, we are saying files. And the system, by using this new library called ranges, is going to understand that concept, the concept of range. A range is going to be starting at the first element and one past the last element. And I want you to take this range specified by this container and pass it to somebody else. And who is that going to be? It's going to be the transform algorithm, right? Because what I really want to do is I want to apply this transformation. I want to lift this transformation algorithm for every single element in files, which is a file name. So this goes away. This goes away. I'm going to just hide these things. All right. And we have what is called a range adapter. OK, again, guys, no need to memorize. None of this is going to show up. I'm just kind of, exploring with you guys some of the things so that you can go back and see if you're interested enough in expanding your knowledge. So this is the name of the range. This is the algorithm that will apply or lift this particular transformation function to every single element of this range. That's all there is. Right? And what does V contain? Many of the compilers are brand new and I'm having a little bit of time trying to kind of figure out what exactly is the type. I don't think it can be manually typed out. So this is where the keyword auto actually has become some sort of a de facto standard. Right? Now I want to accumulate. I want to get the sum. Well, it's very simple. I don't know how to change the accumulate to files, right? I'm learning too myself, but what we have now is lines of code with one transformation function that are going to do the entire thing that we tried to do in that particular thing, right? With that line counting. So now when I print, I should get that stuff. I'm not going to delete a whole lot of stuff because notice I no longer need this, right? Because the job of doing all of this is taken up by this part. That's it. So I'm saying this is my range of stuff. And this guy is saying, OK, I'll do what you want me to do on every single element of this range. You don't need to tell me where to begin and where to end. I'll assume that you want to do this on everybody. If you want to do it only on certain things, there are options that allow you to do that. But let's go ahead and compile. I think we're also running out of time. It doesn't compile, right? So this is what you need to do. So once you do what I suggested you do, you end up with the parallel sort of modern implementation of the GNU. And it's not going to be called G++. Instead, that is the version 10. And you need to specify 20 because that is going to be our thing. And count files was not declared in the scope. Did you mean count files? What was it called? Count lines. See, I wanted to do it without even a single mistake, but I'm cursed. Has not been declared. Is it view or views? It's so brand new that STD ranges. So if I include ranges, then view should work. Let me try. I don't know. Maybe it's where am I? Give me one moment. So we have ranges view. Maybe that's what it is. Is it range or ranges? It's so new, guys, that I'm kind of not completely sort of, how should I put it?
Professor, I think it's ranges and views.
Ranges and no, not views, view. You could be
Professor, I
right.
think because there's a different one. There's ranges views with an S.
Yeah, you guys probably are right. These are the adapters. Do you see a transform here? Yeah, it's views. Absolutely. Thank you. It's not view, it's views. And we'll talk later if you have time about what views is. Basically, what the library is saying is that, you know what, you have a bunch of stuff. I'm not actually going to make a copy of this stuff and make it be unnecessarily slow. Instead, I'm going to promise you that I'm going to get the information that is stored here at the minimum cost, right? And so you are viewing it. You're not going to be able to sort of change it. You're simply getting a snapshot of it. So that's why they call it views. Let's see if it compiles. Excellent. Nope. Accumulated, begin and end. No matching function to accumulate. Is it?
I probably forgot your initial value as the third parameter.
Excellent. I probably had it down there. Okay, finally. Okay, so there. So everything got condensed to these lines, right? Which line 26 is not really required. The most important lines are 27, right? That is the critical thing. And this guy is the other transformation function. So basically all that stuff that we wrote has been condensed to this sort of piping. You're taking the output of this. So we need to kind of figure out, hey, can I actually pass this? So I've been monkeying around, but the literature is sort of also strange. The compiler errors are strange. So it's going to take a couple more years for the entire thing to mature. But at least I think we made some progress, right? So what we have learned is that the way we think about how we want to use C++, you don't want to kind of tell C++ all of the tiny details. Instead, you want to move to some sort of a functional style where you can compose, where you can think of functions as first-class citizens. Functions are similar to variables. You're more worried about what should be done and that is what you should be telling the system rather than how, right? Which is what we were trying to do earlier. We were nailing down every single tiny step. Instead, we are working at a much higher level. We are saying we have something called files and we want to lift the contents of this particular container so that they can be adapted, are transformed, I should say, by this particular transformation function to give you a new transformed range, right? And what is the type of this? It's hard to determine, and I don't think it's going to be actually practically possible. And it's impossible to type it. So auto kind of plays a critical role here, right? So this is okay. Instead, if you really wanted int and you use auto, then there's something wrong in my mind. Maybe I'm old fashioned. Here, there's no actual type that we can specify for V. right? That is the design of the language. And this is how we end up being able to get the whole value. So my aim was to take that little problem that we did in the morning, which is practical. Everybody needs it in their projects, and see how we can actually implement it in a slightly more modern way, right? And kind of think about it from a perspective where you're piping the data so that it goes through all these different stages. And some people call this data engineering, right? All right, guys, any questions? So what I'm going to do next class is sort of briefly discuss the syllabus. I have an assignment, so I need to be able to give you guys that assignment. So I'm going to actually spend some time talking about low-level stuff. It is quite critical. Please, guys, have an open mind. I'm pretty sure design patterns, all these are quite important, and we're going to study them. But you also got to make sure that you do understand the power. And it's so important now that there are so many facilities on C++20 that relate to this stuff. And why? Because C++ is now clearly making the transition, right? It wants to be a low level language. It also wants to be a high level. So they are putting in a lot of stuff from both ends. And so part of what I want to do is talk a little bit about the basic stuff and then get into the modern stuff. All right, if there are no questions, then I'll figure out. I need to kind of do a couple of things. I'm looking at some TAs, and I'm also looking at my own office hours because I have a wide variety of students. So I'm trying to figure out. So this week I'm going to be a little bit in flux, but from next week onwards, we'll have regular office hours and so on. All right.
Sorry, Prof. I forgot the attendance because I was doing the quiz, so I didn't mark my attendance.
Well, you know, if guys, there are 175 of you, right? It's quite critical, and you know, I'm not going to say no to this gentleman, right? But really, it's quite important, right, that you guys follow my advice because you need to help me, right? Otherwise, I'm going to be swamped with everybody sending me stuff, and that is not nice, right? So I'll go ahead and do it for today. Okay.
All right. Thank you so much, Prof.
But
I also need to sign.
Well, let me know, right? But next class onwards, that is the very first thing you need to do, right? It means I'm opening it at 8:55. It was open, right? And so between that time, please get it done. And we don't want to kind of talk about these things anymore. And we're also in the second year, guys. You guys have one more year to spend at the campus, and then you're off at work. All right. So you know, let's get into that mode. All right, I'll speak to you guys next class. Whoever needs that attendance, send me that chat thing, and then I'll fix it. But just because I'm doing it for these guys, I'm not going to do it for anybody else, please. All right, I'm done. I'll talk to you guys on Thursday.
Thank you, Professor.
No problem. And give me some time. I'll put everything that I did today on the course webpage.